There's a mechanism in your car right now that's basically unchanged since 1827, and without it your tyres would shriek and skid every single time you turned a corner. Most people have never even heard its name. That one's coming at number 1, but first, 9 other everyday machines doing something genuinely clever that you've never once thought about. Let's count them down. Look at a zipper and you assume the teeth just interlock like a handshake. They don't. Each little tooth has a hook on top and a hollow on the bottom, and the slider is a tiny Y-shaped wedge that forces one tooth's hook down into the next tooth's hollow at a precise angle. That's why a zip can hold hundreds of pounds pulling sideways, but slides open with a fingertip pulling up the seam. Gideon Sunback nailed this in 1913 after years of failures. Honestly, the fact this survives being yanked 1,000 times a year amazes me. And it's not the only thing hiding a trick in plain sight. Your toilet doesn't pump anything. It empties itself using a siphon, the same physics as sucking soda through a straw. When you flush, water floods the bowl fast enough to fill the curved trap behind it completely. Once that bend is full and running over the top, atmospheric pressure shoves the whole bowlful up and over the U-bend, and it drags everything with it until air breaks the chain with that gurgle. No motor, no valve on the outlet, just a bent pipe and gravity. The whole design's barely changed since Thomas Crapper's era. Speaking of clever water tricks, the next one keeps millions of people alive. Old thermostats and your kettle's cut off don't measure temperature with electronics at all. They use a bimetallic strip, 2 different metals, usually brass and steel, bonded back to back. Heat both and one expands more than the other, so the strip physically bends like a banana. Bend it far enough and it snaps a contact open, killing the current. Cool down, it straightens, clicks back on. That's your fridge, your old oven, the flashing indicator in a classic car. A strip of metal doing maths with expansion coefficients. I find it beautiful that no code runs there at all. Next up, something on your wrist ticking with impossible precision. Your quartz watch keeps time using a tiny sliver of quartz cut into a tuning fork the size of a grain of rice. Put voltage across quartz and it flexes, flex quartz and it makes voltage. That's the piezoelectric effect. The circuit tickles it so it vibrates at exactly 32,768 times a second. A number chosen because it's 2 to the power of 15, so a chip can halve it 15 times to land on 1 clean tick per second. That's why a £5 watch beats a mechanical one costing thousands. 2 to the 15, an engineer's inside joke ticking on your wrist. The next mechanism sews faster than any hand ever could. Here's what breaks people's brains. A sewing machine's needle never passes through the fabric. The eye is at the pointed end and it only dips just below the cloth. As it starts to rise, the thread bunches into a tiny loop, and a hook, spinning below, snatches that loop and wraps it around a second thread from the bobbin. That's the lock stitch, and it forms a knot inside the fabric on every single stitch, up to 5,000 a minute. Elias Howe patented the eye, the point idea, in 1846, and it changed clothing forever. It genuinely took me years to understand it. And the next one solved a problem that was cutting people's fingers off. Before 1975, drink cans had pull tabs that came clean off, and people dropped them everywhere, sliced their feet on beaches, and worse, dropped them into the can and choked. The fix is the stay-on tab you use today, and it's pure leverage. That tab is a second-class lever. Push the back down, and the front pivots on a rivet to press a pre-scored panel inward. The metal's already weakened along that curve, so it tears exactly where designed. Ermal Fraze cracked it, and it quietly ended a genuine public health hazard. A lever and a scratched line in the metal. Now, why did they stop making the next thing entirely? A pin tumbler lock is a row of tiny spring-loaded pins, each cut into 2 pieces at a different height. With no key, those cut points sit at random depths, jamming the plug so it can't turn. Slide the right key in and its jagged profile lifts every pin so the cuts all line up perfectly along one line, the shear line. Now the plug spins free. The whole security is those cut points landing on a single invisible line. Linus Yale Jr. perfected it in the 1860s and your front door still uses it. That's also exactly why lockpicking works. You're just nudging pins to that line one by one. Next, a machine that computed before computers. Long before microchips, harbours predicted tides with a machine of brass gears and pulleys. Lord Kelvin's tide predicting machine from 1872. Each tide is really a stack of overlapping cosine waves from the moon and sun. Kelvin built a wheel for each one, sized and geared to its own rhythm, then linked them all to a single cord running over the pulleys. As you cranked the handle, the cord added every wave together, and a pen drew a year of tides in an afternoon. It's a mechanical Fourier analysis, literally doing calculus with string and gears. The Allies used descendants of it to plan D-Day landings. The next two genuinely stopped the world from making something. Here's one they deliberately stopped making the old way. Early fuses were just a thin wire that melted when current got too high. Cheap, the people breached them with a coin or foil and burned houses down. So we largely stopped making rewirable fuses and switched to the miniature circuit breaker. Inside is that bimetallic strip again for slow overloads, plus an electromagnet that, on a sudden short, yanks a latch open in milliseconds. You just flip it back on. No fiddling with wire. A tiny mechanical trip mechanism standing between your wiring and a fire. And now, when your car turns a corner, the outer wheels travel further than the inner ones. So if both were locked to one axle, something would have to skid. The differential fixes this with a ring of gears. Power spins a cage carrying small pinion gears. Those pinions mesh with a gear on each wheel shaft. Going straight, everything turns as one. But in a turn, the pinions start rolling, letting one wheel spin faster while the other slows by exactly the same amount. The design traces to Onesai for Piqueur around 1827. 200 years old, invisible, and every drive from your house today depended on it. That's the one that gets me. Genius you never see. Quick word from what keeps the lights on here, and this one's really for the